Hello, everyone, and welcome to my presentation on SRC's Digital Shadow Project. My name is Peter Monaghan. I'm in the BIM Change Manager with SRC Southern Regional College. And you'll see I have on the screen the second habit of highly effective people begin with the end in mind. And during this presentation, I'm going to show you how that habit influenced us in implementing our Digital Shadow Project. So first of all, who we are, we're one of 6 colleges in Northern Ireland. We're halfway through a £100 million construction programme across 4 campuses. 2 of them have been handed over in 2020 and 2 of them are at the scheme design stage. And we've been implementing information management and BIM and innovation across those over a number of years and also within our existing estate. So we would consider ourselves to be an informed client. We have EIRs and OIRs and AIRs, etc., developed for our contractors, both in existing and new builds. And we have a digital strategy for 2025. It's made up of 7 strands. The 2 relevant strands to the digital shadow are strand 1, which is about our people. We are very lucky to have a team that are innovative in culture, a can-do attitude, great leadership with vision, and on top of that, that is the most important thing for us, because we can come up with all the great technology and all of our vision about where we want to go, but without the people on board, that just doesn't happen. And it's a relatively small team of 30 people, but it's from all ends of it and all levels, we're all committed. We have a digital twin strand, and our digital shadow is part of that strand. And I'll explain to you later on why we've decided to go with digital shadow at this stage rather than digital twin. We have models of all of our buildings. You can see we only have 6, but we have 2 other ones, but we'll be replacing those with a new build project. So for the 6 that are being retained, we now have models for all of them. And those are a mix of models that come in from new builds, models that we developed ourselves, and models that we got commissioned. This is a summary of a previous presentation where you could see took 3 boilers from a Banbridge project, and up on the left you'll see them in the original MEP model. To the right you can see them in the Ecodomus CAF FM platform that we had. On the bottom right, that's the 3 boilers within our BMS, and it's the live IoT data coming in from that system. And then on the bottom left we have the Matterport virtual tours, which we have tagged with our COBE information. So that gives you a feel about where we're at with the existing estates. We also have been involved with generative design, exploring that, and a wee bit of research on our innovation project. So we're comfortable in these sorts of spaces, doing analysis, doing a wee bit of programming with Python, etc. But despite all that, our data, which is reasonably well structured, it's accessible, it's accurate, but it is in silos. And those silos in some instances have dashboard front ends, but they don't talk to one another. So you might have your CAF FM or your access control or your health and safety data. And some of the silos were not in control of ourselves, and some of them, when we got into this process, we realized they didn't exist and maybe needed to. And so what we were looking to do with this project was, our goals were to bring key platforms, not all of them, in, pull the data in from key platforms into the centre, and to gain some kind of insight to those. And we identified use cases, which we have 10 of at present, likes of asset management, maintenance, health and safety, energy, etc. We wanted also to bring those models that I showed you together with our IoT data, and we were happy with a mix of automation and manual, and we were also happy with a pull to the centre rather than a push-pull. And because of that and that kind of set of goals, we saw it as a stepping stone towards the digital twin, and that's why we referred to it as more of a digital shadow. We didn't want to take the control from the perimeter systems. That was going to create issues around security, cost, etc. So what we wanted was to pull the data into the center, get the insights, and then very quickly be able to go back out to the perimeter and make changes where we could control information in systems that were designed to do the control, your BMS or your access control. And this is where we come up with the idea of our digital shadow as an interim to the digital twin, and we identified the key platforms that we wanted, but we weren't sure about what was in the middle. And this is where the second habit of the highly effective came in, because where we started was with the end, the user interface. And without knowing the software, etc., we decided that what we wanted was to be able to see the use cases. That there was too many use cases to do it all in one interface, so we needed to be able to jump between different use cases. We wanted to separate out information based on campus. We wanted to be able to see the data within the interface, so we wanted to be able to go and look at the actual data. We wanted to be able to access our virtual tours, because what that meant was that our models could be much simpler, and we're generally moving towards simplified models, and we're following the COBE structure, where we have models at a facility level, models at a room level, and models at a asset level. And in this one here, you'll see that it's rooms level that the model's at. And then we wanted to have the analysis on the right hand side, that we could analyze the data, see what was happening, and then down at the bottom we had the links to our key platforms out to the perimeter. And so we built this prototype using Power BI and using the Speckle visual, and we were able to then see that this could work well. First, that interaction between geometry and data. In this particular case, we're just use some sample data around rooms to see how it would work, and we set up our links to the platforms, etc. Our hyperlinks. That's bringing us from the inside to the control area around the perimeter. So once we had this prototype developed, we then, again, that was the end, if you like, and we then moved back the ways to our people and looked at user groups now, and the user groups were based on use cases. Now, we're not a large team, and user groups normally ended up being one or two key people, and we took an approach which was the plain language question approach. So we would have said, if for our estates team, for example, what is it that you want to know? You can see how the interface, the UI works, but what is it you now want to know? What question is it that you want to answer? And that plain language question, they were able to say what it was, and then we agreed with them what visual would answer it. And so, for example, in this one here, you can see that the estates team wanted to know, the question was, what actions have I to take on my orders that are within our CAF-FM system? And so the visual they agreed was a bar chart by campus, which identified the 2 points in the workflow for a task that they had to get involved in and make actions, which were the paperwork being uploaded by the contractor, and whenever a caretaker reported an issue for reactive. And so once we had that visual determined to answer the plain language question, we were able to say from that visual that it only required 3 inputs. It required the x-axis, the y-axis, and then the legend. And when you looked at that, it really only required 2 pieces of information, which was the campus on the x-axis and the status code of orders on the y. So ultimately, what we were looking at in the bottom right is a data set which was made up of your campus, your status, and then a unique primary key. And so we approach this from a data set point of view rather than going back to the original data source. And once we had the data sets, then we were able to say, well, we now know the data set that we require to answer the questions in the user interface. And then we went back to the data sources to say, do you have this information? Is it available? Is it structured well, etc. Some cases it was, some cases it wasn't. And we made a decision then, do we adjust the data source if the owner of it was happy enough to do that, or do we just bring it in and do our transform or calcs within the data set? And so there was a decision, do we do the transform back at the data source? Do we do the calcs back there? Do we do it in the data set, or do we do it up in the Power BI through measures and DAX, etc.? And our general approach was to try and get the data source correct in the first place and to do as little transforming calcs. But we have a mix of most of it happening in the data set. The difficult calcs happen in the data set, and nothing. It's really just pulling data into the Power BI. That left us now moving into conversations about data schemas, the data models, and we centralized our data sets in such a way that the Revit data was at the center, and then our visuals were on the perimeter on a star schema. Now that's something that we have that at the moment, but it has also led us to asking the questions to ourselves around dimension, fact tables, normal form, etc. And just deciding what we have at the moment is a relational database effectively approach, but how do we move that to a graph database with an ontology, etc. And what we're hoping is that with this work, it'll be much easier for us to transform to a set of graph tables if we have a really good relational database that is lean and has exactly what we need in it. And what we ended up with and where we're at the moment is we have, for example, this is the asset management now using the Power BI, and on the left we have the asset register, so they can see the original asset register. It's structured on COBie. You can see the component name, tag number, etc. We have the interactive facility model in the center, and then we have the analysis over on the right hand side. And so and it's categorized according to our ppm rather than just uniclass. So I can select the lifts as a category, and then I can use the model to interact with the data to find a particular lift at a particular campus. And with this user interface, we've also explored this idea about using key documents that we would be able to maintain for campus, and then also having the floor area. So you can see that interaction of data with geometry, analysis, and particular questions being answered for this. This is the maintenance digital shadow interface, and what we have here is the task orders coming through from our CAF-FM system. Again, you have the facility level model in the center. All of this is sample data that I'm showing at the moment. By the way, we found that although it's taken from the correct structure, but in order to test things, if you want to test if something's overdue, you have to make a few things overdue. So our right-hand side, we have the actions that the contractor or LMS will have to make, and we can interact with that, and we can see if there's a lot of actions required, and then the further paperwork required. So we can go in and see what that looks like on the left-hand side, and we can look briefly at the analysis on the right-hand side, and then we can see if any of the orders are overdue start or possibly overdue finish, and that relates back to our KPIs with the contractor. And on the bottom we have the links then through to the key platforms, which are the data sources. So you can get your insight here, and then you can move quickly back through to your plan. And we're using a kind of a 5-click approach. So if we decide there's an order, I can see I'm supposed to do an action, I can very quickly click through to the plan on and go and make that action in the plan on CAF-FM system. And so that's where we're at the moment with the team. Where are we going to move? How are we going to move forward? We are working with the people to again building skills, because what we need is people to be able to go into the back of house and the front of house. So it's a team effort. We don't want just one person being able to understand all of this. So there's a couple of key people that will also go to the back of house. And then there's also the people themselves being able to go in and interact, and not just a fixed dashboard or report, but an interactive. So that's where we're going to be working. We'll be developing the models we've started with the facility level, we move into the space level with the models for the likes of occupancy, etc., and some of the analysis, and then we'll be moving to an asset level, and we'll be asking ourselves the questions: do we do the asset level within these sorts of user interfaces, or do we go a specific model viewer? Because we do have the virtual tours, so we have the best level of detail we can get, and we would prefer to keep our models very simpler for CAF-FM. We're going to be looking at automation. So that idea about, automating the whole process from the interface back to the data sources. We're going to be looking at moving to we're currently using Excel for people to understand that, to get to know the data, but we'll be moving to databases with queries then, and we'll be moving to knowledge graphs and ontologies. And then finally, we have to procure our CAF-FM system over the next 18 months. And so what with this learning, we'll be able to look and say, do we procure a CAF-FM that can also pull data in and do the analysis, etc., and give us an interface with the models, or do we procure a platform that can do the pulling of the data, the interface, and then integrate task orders? Because the benefit of doing that is we already have a CAF-FM ongoing budget, and if we can pull these two together, makes the whole idea of having to find business cases and funding, separate funding, much easier. And once that's done, we'll be moving again towards back to the analysis that we've been doing and optimization. And in particular, we're going to be looking at energy. The original study that we did, the innovation, was around cost, around visual impact, and around energy. So we're going to be taking the learnings from that and applying that. So very much around data, geometry as a sort of an in-text location to geolocate information. And that gives you hopefully a feel. Thank you for listening to the presentation, and that gives you an idea of where Southern Regional College are at with their digital shadow project. Thank you.